In this video, we're going to be going over how to solve trigonometry problems when there are two triangles involved. So we'll first go over an example that's not a word problem. Quite often you will have triangles where they are attached and they share a side or they share an angle, and usually what happens is you have to first take a look at what you want to solve for. So we want to determine the length of AC. So in that case, we are going to label that side as X. That's what we're solving for. But the problem is you need three pieces of information in a triangle to be able to solve for a missing side or angle. First of all, we know that that angle is 25. Second thing is, because that is a right angle, we know that that is a right angle. But we don't know a third piece of information. You need, no matter what the triangle is, you need three pieces of information to figure out anything else. So what would be nice is if we knew this side or this side, then we would be able to use either sine or cos to be able to figure out this missing side. And that's where this other triangle comes in. This triangle has three pieces of information, 1, 2, and the right angle is 3. So what we can do is use this triangle to solve for this side, and then once we know this side, then we have 1, 2, 3 pieces of information that we know, and then we can solve for X. So the first thing we're going to do is use triangle CDB to solve for side CD, and we're just going to call that Y. So in this triangle on the right, in this triangle here, this side is opposite the right angle, so that's the hypotenuse. This side is opposite the reference angle, so that is the opposite. So we're going to be using the sine formula. So sine theta equals opposite over hypotenuse. And substitute in sine 70 equals the opposite, which is y, over the hypotenuse, which is 8. And then you're going to make that over 1 so that we can cross multiply. So 1 times y is y, and that's equal to 8 times sine 70. And there's nothing attached to the y, so you don't need to divide both sides by anything. So in this case, y is approximately 7.5 centimeters. So just remember, if you're not told otherwise, always round sides to 1 decimal place and angles to the nearest whole number. Now what we want to do is look over in this triangle. So we know that this side is 7.5. So now we're going to focus on this triangle. And in this triangle, we know that the hypotenuse is what we're trying to solve for. And there's your reference angle. So that is the opposite side. So again, we're going to be using sine. You won't always be using the same formula. So now we're going to use triangle CDA to find the length of AC, which is what we called X. So that's going to be using the sine formula. So sine theta equals opposite over hypotenuse. And substitute. So sine 25 equals the opposite. And actually, because that 7.5 is rounded, we should be using approximate signs. So that's approximate. The opposite is 7.5, and that number was rounded. So that's why we need to use approximate signs over the hypotenuse, which we're calling X. and you make that over 1. And you're going to cross multiply. So 1 times 7.5 is 7.5 is approximately equal to x times sine 25. And then to isolate x, you're going to divide both sides by sine 25. So that means that x is approximately equal to 17.7 centimeters. So you're in these questions, you're going to be using something in one triangle to either solve something in another triangle, or sometimes you might be looking for the length of this side. So you might have to use this triangle to solve for this length and this triangle to solve for this length and then add them up. It just depends on the type of question. Now let's take a look at this word problem. So it says, 2 office towers of differing height are side by side. The shorter tower is 120 meters tall. So we can enter that in. And the angle of elevation from the top of the shorter tower, which is here, to the top of the taller tower, which is here, is 35. So what you want to remember is angle of elevation starts from the horizontal line and goes up. Oh, that's not the best looking line. All right, so there's the line. That's a right angle. Right there is the angle of elevation. So the angle of elevation from the top of the shorter tower to the top of the taller tower is 35 degrees. So that's that angle right there. That is 35 degrees. So angle of elevation goes from the horizontal line up. Then it says the angle of depression from the top of the shorter tower, which is here, to the bottom of the taller tower, which is here. So now the angle of depression from here to here is 40 degrees. So what you want to remember is that the angle of depression goes from the horizontal line down. So again, we now have a right angle triangle, and the angle of elevation or angle of depression will go from the horizontal line down. So this is the 40. Don't make this the 40. This is the 40. Horizontal down is angle of depression. Horizontal up is angle of elevation. So this is 40 degrees. And what it's asking for is to determine the height of the second tower. So we want to determine how tall this tower is. So here's your plan of action. If you know that this height is 120, then that means the length of this triangle, or this side in this triangle, is equal to 120. So what we're looking for is, if we know this value, then what we can do is take this value and add this value, and we will get the height of the taller tower. Once again, the problem is in this triangle, you don't have 3 pieces of information. You know the right angle, you know this angle, but you don't know anything else. In this triangle, you know 3 pieces of information. This is 40 degrees, this is 90 degrees, and this side is 120. So you have enough information in this triangle, so you can use this triangle here to solve for this side, which we can call y. And then you can use this triangle to solve for x. Because once you have figured out y, then you'll have 1, 2, 3 pieces of information. You'll be able to solve for x. All right, so the first thing we're going to do is use this triangle to solve for y. So in this triangle, this is the opposite side. This would be the hypotenuse because it's opposite the right angle, which means that this is the adjacent side. So according to SOHCAHTOA, for opposite and adjacent, we're using tan. So here we go. Tan theta equals opposite over adjacent. Substitute the values in. So theta is 40. The opposite is 120. The adjacent is y. And when we put that over 1 and cross multiply, we get 1 times 120 is 120 equals y times tan 40. And since y is not isolated, you have to divide both sides by tan 40. And that will give you y being approximately equal to, when rounded, it turns out to 143.0. So that is 143.0. Now in the second triangle, this is the opposite side. This would be the hypotenuse because it's opposite the right angle, which makes this the adjacent side. So once again, we're going to be using tan. So tan theta equals opposite over adjacent. We know theta is 35. The opposite is x. Oops, I did it again. That should be approximately equals because we are substituting in 143, which was rounded. And I'm going to make that over 1 and cross multiply. So 1 times x is x, and that's approximately equal to 143 times tan 35, and that makes x is approximately equal to 100.1. So now, to get the whole height of the triangle, we can say that the height is then approximately equal to 120 plus what we solved for x, which was 100.1. So that makes it approximately equal to 220.1 meters. Now what's very important for communication is labeling properly. So you have your right angle symbols, you put the letters in for what you're solving for. And some people have the tendency to just label everything as x, so they put x, x, x. You have to use different letters because if this is x, that can't be x because they're different values. So you have to make sure you're using different letters.